So let's make this real. First, let me walk you through and explain what we're going to demonstrate today. So you have the high-level pictures, and then we'll go down and push some code. And so we're going to use the topology Sasha presented, and we try to find a use case that is simple enough so that it will not overwhelm everybody with a lot of complexity, but to help you understand the concept, but yet very powerful. So we decided to pick, try to solve a problem that a lot of our customers are expressing. It's just often it starts with the application guys calling and saying, my application CRM is not working. And the network guy has to prove that it's not his fault. And I see people laughing. I mean, you've been there. So the first question is, where is application CRM on my network? So you will start looking at whatever information you have available, and you will try to correlate that with the network and the devices and the place on networks, and you'll go in CLI, and that's how it starts. So because we have this graph database that defines a schema, and it's very extensible, we can start putting in there information that are not just about the network, but for example, adding information about where the applications are in the network. And if you do that in real, you will want to hook that up with your VMware environments or OpenStack to make sure that those data in AOS are 100% accurate. Here, we're gonna change and insert those informations manually, but it's really a matter of making the hook between two systems to really make those informations live. So we'll show you how to insert that in the graph, extend the graph, use new information, and most importantly, we'll show you how to query the graph based on those new information. That will be the first one. Then the second use case, so we'll deploy some application and show you that on the servers. The second will be, now that you have inserted new information in the graph in the intent, we'll show you how to take them to the network configuration. And when you can have a relationship and very easily take those new informations and craft the configuration that you want. And we'll pick a very simple use case, but we'll take and insert application information into the configuration. And the next one, because for me as a network engineer, I'm shocked every time I heard that there are still people out there that think that network automation equal configuration management. I mean, the most important part and interesting part is about validation. So we're going to have an examples where we create new tests, new active validation, and the one we'll do is we'll start having, now that I know which applications and how are state on which server, I want to actively check that the right servers are connected in the right place. So we'll have a simple check that will ensure that. So that will be the scope of the demo for today. And by the way, the topology we're going to use will be composed of both Cumulus and Arista switches. And I mentioned that here because the truth is you're not going to see that for the rest of the presentation, because everything we're doing is at the platform level, very vendor agnostic, and the way you express this intent, the way you extend the graph, the way you push the configurations or define those tests will be non-specific to any of those vendors. So just keep that in mind. I'll jump on some of the Arista CLI at some point, but it's all you will actually see.
How do you model difference in feature sets? Because Cumulus obviously has different feature sets than Arista OS, than Juniper, than Cisco.
Right. So great question. So this is one of our elements of the approach. So we mentioned this concept of a reference design. And in the reference design, we try to avoid the solution that says, well, let me look at 30,000 pages of Juniper APIs and 50,000 pages of Cisco and come up with some canonical model that covers it all. What we are saying is, within my data center architecture, when device plays a role of a leaf, these are the knobs that I need to model in this specific reference architecture. So it's 30 pages out of 30,000 pages. So we actually model those. To model those through configuration, you will see later, we use very similar approach used by other tools today. It's pretty much merger of data dictionary that describes what are the parameters that I need to pass to Jinja template to generate configuration. So it's the reference designer actually comes with a set of what is the data that I need to generate configuration, and the specific features are actually in the Jinja templates.
So there's always discrepancy between what one vendor supports versus another one. If I know I'm running Juno 17 and iOS, God knows whatever versions they use, it might not work, so I might need to upgrade. So could you include version of software?
Absolutely. So you could have a semantic validation that tells you these two versions of software actually don't work.
But those are not hard type defs and semantics. They are just knowledge about feature set support in particular version of particular vendor.
The expectation is that the developer persona who will create this application will pair with somebody that knows this knowledge and will put that into the semantic validation plugin.
So you expect the developer to model.
Whoever is building this application can capture this specificity and make sure that the application works. And if you create a design that doesn't work across all the vendors, that's fine as well. You can use only some of the vendors or.
I'm sorry. The beauty of this approach is that you can have if you wanted to do, you could build very vendor-specific architecture which turns every knob. What you will lose there is you won't be able to replace them, and you can have do data center network using all the proprietary features, automate all of that, and then have another one that is actually vendor agnostic. And that vendor agnostic is going to have a different set of features because you're not going to determine all the proprietary features. But the bottom line is these decisions about which features to use are part of reference design that the developer persona is in control of.
So it's not expected that you have to be an expert in protocols and know all the knobs in EVP, and you would expect someone who is going to deploy it to define features needed and model them.
So,
Well, Jeff, the way these things usually work is someone actually has to figure out how the network has to work.
That would be
to start with. That would be helpful. And then you effectively reverse engineer from there. So you go like, I need this EVPN network, and to get this EVPN network up and running, this is the minimum config I need to make things work.
Exactly.
And now let's figure out what are the knobs I need to, so which things here are variables and which things here are just garbage because iOS or Juno.
Outside of vendor, who can do it? I mean, in ATF, it takes a year to come to conclusion.
No, because
this is the minimum feature set you need to run a feature, right?
No, because you guys are trying to boil the ocean, and every vendor is pulling in his direction because his features.
Not anymore.
Here, oh yeah, sure. When was the last time you were reading IETF mailing lists? Anyway, what we're dealing with here is he as a generic developer, or
tools guy.
He as the tools guy, or me as the end user, or a system integrator developing the glue for the end user. Someone says, well, this is what I actually need. This is not what vendors think I need or what IETF could agree on as the minimum subset. This is what I need. Now let's model this.
Yeah, it's correct. We've been through this iteration several times. We're going to show you another example before the end. This is the demo he's doing. We're not going to walk through the demo of a much more complicated one, but we'll show you what that is. But we've been through this process several times, and the way it works is we're working with network people that understand how it should work, how the protocol should work, what the shape of the network should be, and then they help the developer model it, and then you get your automation.
So you can think of this developer's persona as like there are two sub-personalities. There's a network engineer and there is a tools guy, and these two guys can do.
So I'm very much interested in the process because it's so difficult to come to consensus. What is it you need to do?
No.
So let's get started
This
then.
is the beauty. You don't need consensus here. You need a running network.
So let's get started then, because the goal of the demo is to show you that. So this demo, the 3 demo, will take us through most of the building blocks that compose an app. We'll create Facade APIs, render configurations, extend the schema, touch on the telemetry parts. We won't use everything, but I think it's in a short period of time that we have, it's already a lot of information and building block that we will cover. Sasha mentioned just the unit test. So we have actually, as part of the app, the unit test built in. We have unit tests for the platform, but we have for the app. I think right now we have like 900 unit tests just for the app. And I made the math the other day. We have 3 lines of tests for 1 line of code today, just to give you an idea of how serious we want this part to be. So in terms of the environment, I have the code of the app on my laptop. And it's mainly composed of Python files. We have almost like a one-to-one relationship between a plugin and a file. So we have one file to define the schema, one for the facade. We have a lot of files to define the telemetry for each type that we want to extend. As part of that, we have the configuration templates, the code that render the variables. All of that is sitting on my laptop. And I'm going to use a virtual topology sitting in the cloud with 2 spine, 4 leaves. And next to them also I have my AOS server. So what I will do is every time I do one of those demos, I will change the code locally and I will deploy.
Does everyone know what a Facade API is?
Then
It's an API. It's just, you're just making an API for your app. That's all it means.
in 15 minutes you'll know. Just so they're not.
This is an API that does nothing, but it looks nice.
That's
That's why it's called a facade.
exactly.
It's all lies.
No, it's white paper marketing.
So just disclaimer, I'm not going to write code live because I'm terrible at it. And to not embarrass myself, I actually prepared everything in Git branches. I will just load the code and deploy. I will show you what's happening. We can even check the differences between each demo and see exactly how many files and line of code we had to change. But I will not type live because that's usually where things fail. So let's start with the first demo. How do we extend the schema to add application and capture those information? So it's actually very few modifications we have to make. So this is the schema of the graph that Sasha presented earlier, a subset of it. And if we want to capture application, what we have to do is create a new node, name application, and create a new relationship that will let us link an application with a system. And for us, system is either a server or a switch. In this case, we only want to associate that with a server. That's all that we have to do to extend, and now we can capture information about application inside the graph. If we look at the code, the schema plugin looks like that. So it's really, we have 2 sections. We have the node parts and the relationship part.
Could you use smaller font, please?
Yes.
We were expecting a bigger screen, and but let me.
And it looks better on a non-projected.
Hopefully, people in the stream actually have a better pictures than you. But so what it is it's really like we define what is the node, and a node is composed of property that are just key value. And as part of that, you can also define what is the valid value for those property, what are default options, are there mandatory or optional. So yes?
It's not the highest level object that could have relationship with other nodes in peer-to-peer fashion, or there's hierarchical relationship between nodes?
There is no hierarchy. It's a graph. Any
Okay.
node can have
So the relations are defined by the relationship. So you create the node type, and you define them, and then you can, as long as you have a relationship that say that you can now have your system node connected to interface node, then you have a relationship. And you can add as many nodes as you want and as many relationship. And it doesn't break. You can even extend and add new property on an existing node. The system will not matter.
So again, very good question. This is one of the reasons why we chose graph, because if something is hierarchical, hierarchy implies already opinion, and then somebody may need to break the hierarchy. In graph, there is no such thing as hierarchy.
For me, graph was honestly, I mean, I've been in the network industry for 15 years. That was a shock when I came here, because it's one of those technology that is very mature, used by so many people out there, and that personally, I never heard about it. And I didn't know about it. And I was like, I'm like, I have a lot of software skills, but I didn't know about that. And it's actually very interesting and mature technology that lets you organize that. And I'm very surprised when you see how much it fits the network.
Can we take for a second out of FAT3 topology into service provider environment? You've got a service on top of your basic reachability, on top of your LSP, on top of your OTN, on top of your optical network.
Yes.
How do you describe relationship in the graph?
It's up to you. You will probably create a node service and associate that
I can
with.
explain. So there is an interface object that is going to have relationship composed of other interfaces. So you can have physical interface, part of another layer of logical interface, part of another. Interfaces at each layer can be connected with links. Now, link itself can be layered on top of other links.
Okay.
So you can create the same. I've been through TMF 814, so I know how to
I know.
So apart from performance, I could model this in a SQL database.
Yeah, one thing is that's really
But
Let me finish.
what's more interesting, going back to your question, can you say, well, I already defined an interface. Can I now extend this interface and create an IP interface, which has all the same things as an interface, plus an IP address?
Yes, that will be just another type of node.
So I have to define a different type of node.
Different
I can't
type.
extend.
Right.
No.
So
So you don't have class inheritance.
We don't, and
Okay.
it's a conscious decision.
Yeah, sure.
Class inheritance gave you a lot of benefits.
But it's
for
messy.
use. Well, it gets messier if you get it wrong. It's very difficult to change.
Yeah.
So
Okay.
to answer your SQL versus graph. With SQL, you can do query, but there's a lot of study that show that as the number of relationship grow, and as the data set get bigger,
I was writing SQL queries. You don't have to
Okay.
persuade me.
perfect.
But again, keep having in mind that this model is a model for one reference design, and it doesn't have to address every use case. So it's not overloaded with things that you may never use.
So if I want to add application, I had a node, and here it's a node very simple with just two parameters, the name of my application and potentially an owner of my application. And I will create a new relationship that's allow to this node application to be associated with my system node. Just by pushing that, I already get a lot. The schema will get extended, I will get APIs, I will be able to query the graph, push informations. All of that will be provided by iOS Core. Now, we have this Facade API, and what it is, it's a plugin that lets you, with very few lines of code, create your own facade, your own REST API, and you have more control about the documentation, and you can put together more logic. So you can bulk some multiple operations behind a single call and implement your own logic here. So in this example, I'm creating two Facade API for the example, one to create application, and one to associate my application with my server. So
Okay, so do you have to create this by hand, or is the API created automatically from the schema and you just have to
Yes.
fill in the blanks?
The node relationship level API is created automatically. You don't have to write Facade, and you can create all of this by actually posting directly nodes and relationships. What this is doing is giving a Facade to actually in one shot create an application. And again, this example is not so powerful, but let's say if you were creating a virtual network. And virtual network, as you saw the model, I have to create multiple endpoints, relationship with endpoints to hosted servers, virtual network. The moment you define the schema, you can write those APIs at the graph and relationship level. You don't have to do any line of code. But if you want to have Facade that says, create a virtual network with 7 endpoints on this server, you can do that.
No, the question was more along the lines, can you create the template for me? And then I would just fill in the blanks, like the business logic. And I don't have to deal with 80% of the fluff that has to be there for syntactic
that's kind
reasons.
of the Facade API is doing as well. Like you very quickly, just with this line of code, you will get authentications, documentation,
That's
schema
precisely the
validation.
purpose of Facade API.
So just by defining that, you define what you want as an input and output. So it's the schema of what you want. You will have validation on before and what's coming in, what's get out.
To make sure I properly understand, Facade API is auto-generated based on your data model, correct?
No.
That was my question, thank you.
There is a node and relationship API which is created automatically based on a schema. That's not what we are showing you here. This is something on top of that if you wanted to actually have something, as Ivan said, create me some template. And again, this is again subtle decision that we have made. You could have thought about, well, why don't I create some super data model, have everything data driven, and I don't have to write any code? Well, you could do that, but the data model will become very, very complicated. So it's actually balanced. What do you decide to model with the data, and what do you want to model with a little bit
No,
of code?
what we are both saying is we would love to have an API that would be auto-generated based on the data model. So I don't have to specify there that I need the name and the owner and yada, 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 yada. But
Intent-driven
of
API.
course, the business logic is mine.
That API is auto-generated, except that it's down one level of detail. So this is where the word facade comes in. What that means is you have a complicated set of, let's say, API endpoints in your product. And you don't want someone who wants to write against those APIs to have to hand do every single minute call to build everything they need. You can collect a bunch of information up front and then underneath make all the calls for them.
It's a wrapper.
And that's what Facade
So it's like a UI wrapper.
Yes, it's a
But
wrapper.
the alternative approach, Ivan, is you could define a node which represents this template. Let's say this node represents my service, has all these parameters. And as you will see, we have these reactors that actually react to the creation of that node and do all this magic in the back. Yeah.
So you define the URL, the type, and you have the mean to implement your own logic, and you can put all business logic you want in there to package that. So I'm creating 2 of them for this demo. Before going into the real code, let's look again at the schema and not at the graph and how it will look like. So as what you see here is now we have application nodes that are attached to host servers at the bottom of the graph that Sasha was showing earlier. And again, if it's not clear, what does that give you as a network engineer? Is now you can query the graph with something that say, I want to know all the switches, the interfaces, and the link in my networks that are used to communicate between the 2 servers that are part of application 2. And you will be able to express this query in a very readable way, and the system will return all the information that you have in this application. And now if you extend and you say, now I also have this application on the 3rd server, the query will remain the same, but the results will be extended and you will get all those information.
Okay, now the trick question from yesterday. If I have unequal cost multipath, or if I have primary backup paths, will your model give me the currently active path, or will it give me all the potential paths, including the currently inactive backup path, or something in between?
So as a tool guy, let me answer that question. If you model the links to carry information, what is the primary and backup path? The answer is yes. You can write a query which will say, give me the paths whose property primary is true, for example.
But let's say the real problem I have in my network is that I have this primary and backup path, and the primary path goes down, and so the latency increases, and the phone rings. Now I want to look into your tool to see where the traffic is flowing.
Okay.
How would your tool know that because the primary path is down, now the traffic is going over the backup path?
It is going to. You can run a query says, give me the path between these 2 nodes that doesn't go over links that are down.
Someone has to compute the backup path.
Huh?
You need to have your LSDB run SPF against it, prune the primary path, and see
This is
who
the
is
kind of
next.
intent this is the reason why we use this model. If you think about it, redundancy is something. This is one of those things that's in your head, right? And you have an idea of how it should work and how the design is, but there's nothing inherent to the configuration or network state that tells you this is the primary and this is the backup. It's usually something you know or that you try to infer.
No.
Well, but there is
Your cost structure.
Okay,
You can model that.
There is an
now I
instrument-
get it. You know what you could do? And they have to reinvent SPF to do that, which of course they would do. You could say, give me the minimum cost path between these 2 nodes. And then you would see where the traffic is actually flowing, because that's how routing protocols happen to work, or at least you hope they do.
No, because you already have a graph, you have a cost associated with every link in the graph. You just need to run Dijkstra or Steiner of their algorithm you use, right?
Yep.
So do you do this?
If you want that, you can. We don't do this right now, but again, it's.
Well, you could query for minimum path, for minimum cost path, and so you just turn Dijkstra into NP complete problem.
There's a distinction here, though. We've been, yesterday we talked to Veriflow, and that was a model. This is not a model, as I understand it, because you guys have a closed loop that actually talks back to the infrastructure, and you're pulling all the data back out of the actual network to determine what that graph looks like.
Right.
Okay, so from that, now part of the information you could extract is what, not just the primary path or the equal cost paths, but paths that are secondary or failover paths based on, you could query OSPF link state database. You could query EIGRP if, God forbid, someone was using that for their large data center. And find that failover information, what happens next.
Right.
Do you pull that information out as well?
Not by,
It's a job of reference designer. You say, because let's say we're not doing it now, and you say, well, I want to do this. Well, we need to start pulling this telemetry this instrumentation that is going to give you associate these attributes with these links. And then when you run a query, you can supply these constraints in your query.
Such a
And
fundamental
don't show me the
Can-
primary.
Yeah.
Don't show me the primary. So if this query shows me links that carry app-A2 traffic. If I wanted it to show me, the secondary links or links that could be used if these primaries were not available, the links that are going to get used next, it would tell me that.
When you say
Again, you're saying it could, so that's what we're trying.
Ethan, what Veriflow is doing is they're taking data plane information and they're reverse engineering the model based on the data plane forwarding information.
Yeah, which is not exactly what's happening here.
No, what these guys are doing is you are starting with the network diagram, and then you transform that into configuration, and you transform that into desired state.
Yeah.
So they would tell you if the actual state deviates from the desired state, in which case you would be the one who has to fix it. But they are not pulling yet the information from the data plane,
Correct.
saying, well, your traffic, we think your traffic should be flowing this way, but oh, by the way, it's actually flowing that way.
But another way to think
So
of
each one of them is solving half of the problem.
But there is data plane being pulled here.
You could,
whether
but
you pull data plane or not is a reference design decision. You could have a plugin that says, I'm going to run a Veriflow plugin here that pulls this data and instruments this graph and then get that information.
Sasha, the fundamental question, can you model future state based on graph, or you assume there's an application that you'll expose through machine-to-machine interface through APIs, for example, your LSDB, and that's going to count or compute who is the primary, who is the secondary, who is the backup? What's your approach?
Again, could you calculate that? Could you run that? Could you write that application? Yes.
So his approach is, I'm giving you the platform, you do the hard work.
That's what I think. Nothing wrong with it, just try to have better understanding.
If we did it that way, it would be opinion, and people would say, well, I don't like that, I want to do it this way. So yes, we have reference design that are very opinionated, do it this way, but if you want to knock yourself out and do whatever else, yes, we want to show you the tools to build the latter.
Understood.
It's another SAP platform. The way you compute the payroll is your decision.
Guys,
Except for the turnkey solutions that
love the discussion. I'm just, we got to be mindful of time. I think it's a lot of
I want
points.
to base one more myth very quickly here, which is there is also this preconception that intent-based networking system, the single source of truth is only about the stuff that you manage, and it's not necessarily true. And actually, your application is going to play in some environment. So for example, we're not managing application, but we want to know about application because it's very important for reasoning. If you build data center fabric and you need to talk to routers, you want to model these routers external points and have them updated through APIs, and they become source of truth because they impact how you do things. So again, this graph model allows you actually to model your environment as well.
Okay, demo time. We're ready. So here's the AOS UI. We're not going to go in detail again.
Quick
I hope.
question. How many of you have watched this NFD 13 video that with operator persona last session?
I was there.
One and a half.
You were there. Why aren't you?
I was like, I think I
Amy
was
was-
there. I didn't watch the video because it
Okay.
was live.
So if you want more information about the operator persona experience, watch that video. But this is part of it, actually.
Yeah. There's a whole UI for people that don't want to write code, and just wanted to show first that there's a documentation for the APIs embedded with the platform, and
Yeah, Wi-Fi is not that
I
good.
hope the network is with me today. Here we go. So what we see here is all the Facade APIs that are already part of this reference design. I'm showing that because I will deploy the new code, and as I will do that, I will get my new APIs. I just wanted to show the before and after. So let me deploy the code. So I will load what I have. And I will deploy that to my server. So it's gonna take few minutes, few seconds to do that. And once the code has been deployed, I will be able to create applications, query the graph, and I will show you that. Because we'll have the APIs, but we know network engineers don't like APIs. I actually have written a very small CLI tool to let me interact and create application. And so I'm gonna install that as well. And hopefully everything is working. I'm still waiting for the server to reboot. And so we'll start creating application, associating them with some server, and I will show you how we can query that. So the server has finished to reload. So let's first look at the REST API. And we see now I have two new REST API. I have one that defined that let me create the application. I have all the documentation that has been generated from the schema that I define as what is an input, what is my output, what is the documentation. All of that is following Swagger. So,
Yeah. So, I mean, he just added API endpoints on a live server, and they now appear in the Swagger documentation. So you can auto-generate skeleton code for, the new endpoints in Python or like some other bullshit language you think is better than Python.
So now let's create application.
An old Perl guy is happy.
I used to do Perl, don't.
That's some bullshit.
So let's say I want to create my CRM application that is owned by the sales guy. So I will start adding and feeding those informations into the graph. So let's say I want an email owned by the IT department. Now,
Did everyone just realize that he's using Slack to configure his network? Which is like awesome.
So
We were supposed
I
to
want to
jump
point
into
something
that.
out, right? That was there was a point I'm cute. I'm supposed to be like, oh, I'm feigning surprise. when we did this,
Sorry.
when we did rehearsal like 2 days ago, our first rehearsal, Jeremy and I and Sasha had never seen this, and we were like, "Are you using Slack right now for the CLI?" And he was like, "Yeah, it's not important." Typing away. What the hell? You have to talk about this. This is really cool.
But
No, it is
probably
really-
lost.
is there
It is,
another
Chat.
chat
And
there?
then, hold on, this gets better, right? Because yesterday, Mansoor, CEO, comes in and he's wanting to see the presentation. And like 30 minutes before Mansoor is supposed to show up, he is sweating, right? And his face is like turning white. I'm like, is everything all right? We're gonna be ready? He's like, yeah, we're gonna be ready. It's just that I deleted all of the code from my CLI and I didn't back it up to GitHub. So in less than 30 minutes, he recreated the plugin for Slack.
What do I prefer IRC?
So
You can
actually
IRC Slack gateway.
the framework
Stop
I'm using, the framework I'm using to do that also support IRC. So you can use the same command.
You are my hero.
I'm sorry I did not set that up today, but it will actually
So
work.
remember when we said we don't want to be religious about architecture, it's about feature velocity. So
So to show you now, if I go on the platform, we talk about it. What's really powerful with the graph is the queries, and there's different language and way to query the graph. One that is very popular and it's almost a standard today. It's an interface named GraphQL, which lets you query a graph, and it's a language that now a lot of people have embraced. So to show you, for example, here, what it gets us is auto-completions. As soon as I update the graph schema, I get the documentations, I get all those information now that are available. So I can see like my application
this is the
node.
auto-generated part. There's
All this
no
part is
facade.
happening just because I changed the schema. So now I can query my graph and say, okay, I would like to get the label and the owner of my application in my graph. And I see that I have the CRM and the sales. And as I will start adding those query now into those information in the graph, I will be able to traverse and in the same query get the servers and all of that. So I also created a small tool so that I can actually run those query directly from the CLI. So I was talking with a customer and he was telling me like how useful, because you end up creating a lot of those query and you got to build a library. And every time, for example, you have in maintenance windows, you will want to create your query that gets you the information about the device affected with that. And so it's really something very dynamic. And we thought that it was great to put that as in Slack.
Yeah, so basically, I mean, we have a customer that's adding CLI commands to Slack prior to maintenance windows so that those commands are ready to go to whoever's doing the maintenance. They can capture and share the screen with whoever they're working with for those commands.
Yeah, that's the great thing of if you use Slack, because then everyone can see immediately where you messed up.
Exactly right.
And start yelling at you. No, that's the idea. Simplifies troubleshooting.
Crowdsourcing.
So now I'm mapping with another command my applications to my server. So I say, okay, my CRM is on server 2, and it's also on, let's say, server 4. And I already forgot what I created. My email application, let's say, will be on server 1 and 3, or just on server 1. So if I go back to the query, now I can say, okay, I would like to get the list of my server for each application.
Now.
And because there's relationship, it's auto-completion, now I can query those information from the graph automatically. And as you extend, you will get those information. You can add a lot of, you can say I just want for this application and so on, but all of that is
part now a question you probably wouldn't expect to hear from me. Can you turn that into a real eye candy graph?
What do you mean?
Not JSON?
So right here, because personally I hate JSON. So the way I did it here, I convert that to YAML on the fly. I don't know if that helps.
Yeah, okay.
Cool. I created another one where I say, okay, I would like to get
Stay tuned.
Tab details, CRM, and for example, here what I'm doing is I create a graph, and I just extract the information that I want. For example, this one tell me, okay, my application CRM is on server 1 through this interface, and this is the Ethernet 3 on my top of rack and this top of rack. So I just extract what I want, and I make it in a form that is consumable by
so that tool you were showing there is more for the developer to see what he could get out of the query and what the data types would be, and then for the normal human, the developer would generate something like this.
Yeah.
This is developer's persona.
Yeah, okay.
Why is the first line indented?
That's a bug, man.
1 out of 10 would not use.
It's Slack.
That was the first part of the demo. I'll say there's more demo to come. So let's continue with the build phase.
So let's speed up through Sasha time. We want to have more demos and less talking. So build phase, we discussed what are some of the choices during the build phase. You want to do is say, I want all my Fabric interfaces allocated IPs from the pool, because I don't care what they are. Or you may want to say, I want them unnumbered, or I want to specify them explicitly. But whatever you choose, it's again part of intent, and it needs to be captured. And then you may add semantic validation, say, do not deploy otherwise. But again, you'll be hearing this concept of need to deal with the change, because the tough part here is, it's easy to push these IPs once, but how do you deal with change? Like somebody adds a link. This reasoning at the build place is going to say, well, gee, I detected a new link, and I'm going to auto-allocate it from a resource pool. Or if the link is removed, this needs to be released back into the pool. So now the question is, how do we deal with that? And I wanted to explain you this live queries pattern that is the foundation for all of our reasoning logic. So what happens here is that there are 3 elements in this live query pattern. One of them is, how do I express my interest in set of data that I want to be notified when it changes? And I'll show you that. But let's say there is this guy who is subscribes to a blue query, and blue query could be, I'm a leaf, and tell me if any of my spines have changed. Then you do something about that. And doing something about that, again, is done via Python module. And what you can do are different things. And among other things, you can publish something back in the graph. Create some other nodes that may help you with some other analytics. Or you can generate errors. Or you can write logs. And the last piece is, how is this data actually delivered to you? So to show you that, I want to give you an example of developers' tools that we have to actually help developers write this.
Okay, I know you'll say I'm a tool guy, I don't care. But from the operations perspective, can I subscribe to a link going down and then change the intent to enable a different BGP interface so that now I'm on a backup path?
Yes.
Yes.
And automatically push that into the network and deploy?
Yes. I'm a tools guy. I need an engineer like that to tell me that.
You're asking as a network person, can this be done? And you would work with someone to model and implement that.
Yeah.
Absolutely. So again,
So you can, through those Facade APIs, go back effectively into the build phase and deploy phase and
Yes.
make live changes on the network based on whatever event you subscribe to.
yes.
Yes.
Okay. Cool.
So,
It just needs to be programmed.
but
You're not
scalable,
cool,
testable, and maintainable fashion.
Yeah, and write unit tests and all that stuff.
Okay, so what does this query? So the query to express interest looks something like this, but I'll actually walk you through an example here. This language is, for people familiar with graph database, there is a Gremlin language, which is an open source definition. We also have a parser for Cypher language, which supports a very popular Neo4j graph database. Again, it's a simple matter of parsing. Now, so how does it work? This is again, developer's tool. This is the graph. It's a subset of a graph. We have chosen just to see few classes. We have grayed out the rest of them. You can click on the node, see the properties. But what's important is let's start going through this. Let's execute the query. These are actually snapshots from this tool. So what's going to happen is we're going to show you the steps how this query actually executes. So you say, starting from node of type system whose role is spine. So that's the first step. And it says, well, OK, I got 2 of them. Then you say, get through any outgoing relationship. Actually, you could be very specific. You could specify the name of the relationship here. You could specify any key value that this relationship or node has to filter out other options. Then you go, well, I want to get to the node of type interface. Then again, go out, get to the link, go out, get to the interface. And the reason you see in and out is because relationships are directional. And then finally, when you get to this is interesting part actually. So it's going down here. This in our model, these were the links that are going to the external router. But finally, when you hit this node of type leaf, that guy is now not matching anymore. So this is your complete match.
Sasha,
Yes.
what if I need to go up the tree, in particular case, not down?
There is no tree.
You are
graph.
walking tree down, right, from spine to leaf. No,
No.
it's a graph, I understand. But
Yeah.
you're going to, what if I need,
To go from leaf to the spine.
in particular cases, yes.
So you would have starting from node system role equals leaf. Go to
No, or you would start with node row equals spine, out through interfaces to node leaf, out through interfaces to node spine.
Yeah. So
It's
there
a
is what we can
breadth
talk
search.
about. A graph query language is, we can spend 2 hours on that.
Sure.
But, and now, so this is all the set of results. And now how are they delivered to you? They're delivered to these callback functions, actually each match one at a time. So you react to all of them. And why is this important? It's important when you start initialization, you start it from the scratch, you're going to get 10,000 links. But again, in AOS, initialization is treated the same way as a change. So when you make a change, it's the same mechanism, except you're going to get just one link. And again, here are all the paths. It says there are 8 of these matching patterns, and I'm going to walk through them. So this is one, this is another, this is another, this is another. And your callback function gets all of that. So actually, you don't get just the link. You get, because you wanted to get also this context, what are the neighboring nodes. So we don't have demo for the build phase because it's boring. We're going to go to deploy phase. And we don't have time. Deploy phase, again, is about rendering configuration. We're going to show you how we do that. As I mentioned, there are a few other options that are part of the intent as you do configuration. But let's focus on what does this live query look in case of rendering. And this is not a rocket science. This is how it's done today. And we pretty much, there is one important difference, again, which is how do you deal with change. So we have this live query that I told you that operates on this graph and does something. So in case of rendering, what it does is it collects the context that is important. So if I'm a leaf, I want to know who are all my spines, what are their IPs, what are their ASNs. I may fetch some policy, and I put that into something we call device model, which is a fancy word for Python dictionary or variable files. And these variable files get merged with Jinja template to produce config. Now,
so effectively, you would run the query that would say start with device, collect all the interfaces, collect all the adjacent nodes because I might need that.
Yes.
And then you get this hierarchical dictionary of dictionaries of dictionaries. You push that through a Jinja template, bam, you have the device config.
Yes.
What's
And
very
you can fetch security zones and
Yeah, whatever.
Yeah.
What's very important is because I was using all the tools out there that people use to automate network. And I'm surprised that we don't talk enough about the challenge to manage those variables. And people end up having one set of variables for every device. And the truth is, most of the time we have overlap. So we start having duplicate type of information. And when we initialize, it's easy, but when we want to add new VLAN and things in the network, that becomes very challenging to maintain all those sets of variables.
That's because they're doing it wrong. Come on. You need fabric data model.
Okay, so let's not waste time on doing it wrong. Just kidding. So let's move on. So let's say you start from a blank slate. There is nothing in your system, and through a web agent, you publish this beautiful design that you want, and let's say it has gone through the build phase, and resources are allocated, and you want to generate configuration. Well, config rendering agent, and we are showing one which works for this leaf, runs that query that we just described, and he says, I want to get all the links towards spines, and I also want to have interfaces towards server. Extract this information, put it in the dictionary, merge it with Jinja template, and the same guy publishes configuration, which is now associated with the leaf. Now, there is a device config agent which subscribes to changes in this config, and when the config is changed, he goes and deploys that. Now, that was the initial case. Now, how do you deal with the change? Well, the same way. So let's say somebody through a web agent or through this Slack channel goes and modifies ASN number on spine 1.
Sasha, is it transaction-based? Can I roll back every transaction, or do I have to roll back?
So the way we deal with transactions, we take snapshots of a whole intent, not of configuration. So you roll back to a version of a blueprint that was before. Yes. And again, just for note, we don't store these configurations. They're actually just calculated on the fly, and then pushed to the devices. But again, going back, let's say you say, I want to change ASN number on spine 1. You can make semantic validation to actually prevent you from doing it. But let's say you did that. Then all the 4 leaves who have this query pattern saying, I need to be notified if something changes on a spine, get notified. And each leaf's model gets auto-updated with this new ASN number. And then configuration gets generated, and then configuration gets pushed. And now, small diversion. To tell you, we showed you all these tools that are at disposal of developer persona, and now we want to tell you what is some of the stuff you don't have to worry, and you don't have to worry because AOS Core does it for you. And that is, how do you deal with managing change at scale? So our decent size graph looks actually like this. So now if you say, how do I react to change to this thing? And again, classical approach is decomposition. Decomposition here again means having ability, it goes back to live query pattern again, which means I can have a different set of agents and processors operate on parallel on a small subset of the graph. And they all care about their area of interest. This graph can get extremely complicated, but this guy is focusing only on this aspect. So the complexity doesn't go exponentially as the graph gets bigger or more complex. So with these multiple agents, you actually can cover the whole graph. And then again, because these are stateless agents that execute as separate processes, they can execute in parallel, and we can scale horizontally because you can add more processing agents. Enough, Sasha. Demo time.
Thanks, Sasha. So the second demo, if you remember, was about how do we take those informations about application that we have in the graph now and use that to change the configurations on the device. And we decided to pick a very simple use case. So probably something you won't want to do in productions, but the idea is that we will change the description of the interface facing the server with the name of all the applications hosted on this server. So on the leaf, we react to the information associated on some other part of the graph. And I understand that things are changing so fast in productions, that's probably not something people will do, but that will get us through the process and an easy flow where we will actually see config getting deployed on the device. So what we have to change is one file, is the configurations rendering, and all we have to change is these variables that are fitting to the templates. And what I have here is really two sections. The first is query the graph. I need to get the information I want. So I'm using exactly the same language that Sasha showed you previously to say, for each interface, I want to get all the server attached and all the application attached to this server, and I will get this list. And when I get this list, I will, in Fulite, implement my own logic to craft a new description for my interface. So I will deploy the code, and before, again, let's do the before and after demo. So if I go on my leaf 2, it's an Arista device. If I look at the configurations in AOS here, you see that the description, so Ethernet 3 is the internet interface facing my server. That's also what I got from the query on Slack earlier. And it's here, right now, I just have the name of my peer. So I will push my change, and immediately you will see that now this description will change, and I will get the list of application. So again, it's going to take a few seconds. While it's going on, let's look at the differential between those demos, just so that you really see that I'm not making things up. It's really the code I'm pushing. So the first demo, for example, it was, I only had to change the two files I told you. Like this one is documentation. So I really had to change a facade and change 56 line, and had the schema, and I had to change 9 lines. So it's all the code I was showing you earlier. That's all I had to do to implement the graph, the query, Facade APIs, and all those new features that we were showing in the first demo.
Okay, so you were working with the code for the layer 3 class application.
Yes.
And extending that code by adding new elements into the schema, yada, yada, yada.
Yes.
Yeah.
Which means that me, as your customer, would get all the source code that goes with all the applications, so I can extend it.
Yes.
Okay.
With the source license. And absolutely.
So simple example. Imagine I want to apply policy to all eBGP peers, outgoing policy. How would I group it, and how would it done? I have single label for all eBGP peers. My policy is the same. Last week, not to mention large company, leaked 50,000 prefixes in Japan, right? Because they just didn't filter out non-MTIF pass prefixes. How would I apply such policy to all eBGP peers, not one by one?
Well, it's not applied on one-by-one basis to begin with.
So how do I label all eBGP peers as a single class and apply policy to all of them without going into semantics?
You would add a key value which indicates eBGP role or something like that. That would indicate that this, in your reference model, there is another key value that identifies who are the eBGP peers.
So I would have a label, and I would just switch. Okay.
So it's we're coming on 9:30, and if we'll take questions at the end, but we should definitely.
Okay.
Yeah. So I pushed my code, reloaded the config, and you see here, not sure if it's big enough, but you see now I have CRM listed on my leaf 2. And if I go back to my app, and now I say, I actually want to have email also on my leaf, on my server too. And you will see that's where all the live query and the dynamic part of the product will be in place. That as soon as I push that, immediately configurations get re-rendered, agents have been notified that the change happened, and then I reload my configuration. Now I have CRM and email as part of my configuration. And if I were you, I would actually be scared now. It's like, oh, every time I had an app and relationship, I push configurations on my device. That's pretty scary. And that's a good way to introduce this notion that we have internally, which is when we push change to the graph, we have different type of graph. We have one that we consider as stage, and we have one which is deployed, active or commit. And you have the control on when you want to take your changes, all of them, and deploy them in production. So right now, actually, all the things we've been dealing and adding applications was on the stage graph. So none of that has been deployed on my network 4. I was just preparing. If I go on my leaf, we'll see that right now I don't have any configuration that's been pushed. And as soon as we will press commit, then all my changes that are in stage will get deployed, and my role configurations will get active. There's this
You
annoying.
could probably deploy through Slack, right?
If you wanted to, I did not create this one, but, but it's a very good. I could absolutely
It's very smart,
deploy
but it's
from
lazy.
All smart people are lazy.
So
That's right.
So you see here. If I look at my device right now, Internet 3, the description has not changed. So now I will go back on my system, and I will say now I want to deploy and commit. And all the changes that were pending now will get deployed, and the configurations will get updated on the device as needed, and it's really fast.
I might have missed this, but when you do, when you stage the config, do you write your own test to tell you what it's going to mess up, or are there built-in tests that it's going to say you're really going to mess this up if you deploy this code? How's that?
You
could
yes,
test the tool.
exactly.
Okay.
You can write semantic validation
Yeah.
to say whether you're going to mess up something and put the rules there. But if you're asking, are we simulating pushing this configuration and have some, no.
Again, for us, what the part that's really interesting is the next one, and I don't want to jump on that, but it's a validate, and that's the last section, the last demo we're going to show is how now we are actively validating, reporting alerts. I think it actually answered the past questions, and all of the things we've been talking about is related to that. So let's go to this one.
So validate phase, again, very, very important, if not the most important one. So what happens during validation phase? So when we founded the company, David Sheraton, who is one of the founders, told us, we software engineers come to work every day to write bugs. and then it's the job of tests to turn those bugs actually into features. So that is a well-proven
That explains.
well-proven software development methodology called test-driven development. And again, this applied to networking means exactly the same thing. I want to first define what are the artifacts of the service that I want to validate and ensure that things are working up. And then I start pushing configuration, and until I get all the greens, I'm not done. And again, even more important, even in test-driven development, there is a refactor phase when you introduce some change. So again, this notion of change is something that we keep repeating, but it's the trickiest one, because how do you ensure that your beautiful new change did not introduce regressions? But what's happening, you have 800 of tests running, and when you make a change, all these tests still need to be passing. And again, translated into network engineers' life, it's, well, when I make a configuration, did I screw something up? Well, if you did, you're going to get a set of anomalies generated immediately. What does it look like? Again, same story. Let's say I take leaf 2 out of the service for fun, or not for fun. So what's happening here is these two spines have this leaf returned in a query, and you want to say, I want to have BGP sessions with all the active leaves. But if somebody takes this leaf out for maintenance, it goes down. You don't want to be flooded with alarms and saying, well, it's down. It may be a good thing because it's going to tell you somebody is doing it, and you can have a policy to say, well, that's okay. But actually, if you want to suppress those, you simply say, well, no. If this thing is taken down, I can actually be notified when it's taken down, and this expectation rendering agent is going to say, well, do not expect to have active BGP session with this leaf. So that's what he is going to do. He's going to publish here the correct set of expectation. Device telemetry agent is going to be collecting immediately, reacting to these changes behind the scenes, and then anomaly detection agent is going to generate correct anomalies.
Sasha?
Yes.
Could you try to figure out cascading failures? What happens if 2 nodes fail? What happens if not 1 fail and then not 2 fail?
I would love to. Can we sit down and do that? You'll be a network engineer and I'll be a developer persona.
Sure.
And again, just quick summary. We've been talking a lot about what are these tools that are given to developer persona. So if you look at these red colored items in the middle, we give you access to schema definition. And then if you look at these red parts in these stateless agents, we give you access to processing. How is this data processed? So not only there is a nice separation between state and processing, but actually you have access to both of them. What you don't have to worry about, and you don't have to worry about because AOS Core provides it for you, is these blue lines, which is how do I scale this large distributed state? How do I create this logical communication channel between this agent using this pub sub? With that in mind, final time.
So the last use case was about, out of the box, this layer 3 app that we have, we actively check the cabling between the spine and the leaf, but we don't check with the servers because it requires to make sure that LDP is enabled, and so by default it's not there. So what we're going to do is we're going to create those expectations because now I want to know if my server is really connected where I expect it to be, because when I get my query, I want to make sure the information I have in my graphs are true and accurate, and things change all the time. So we're going to create an expectations and deploy it. The code for that looks like that, and that's really a live query. So what we have first is we create this query, and basically with this Python decorator, I subscribe to the graph, and my query here say, I want to subscribe to all the leaves that are active and that are connected to layer 2 servers. That's what this query means. And for every time something will change in this path, I will be able to create my expectations and build a dictionary and put that in my expectation store. One part that is very...
I wonder where this states ready or deployed. These are the ones for which I want to see the session. So if it's not that, don't generate the session.
What's very important is when I get these callback functions get called, I also have the information about all the information in this path, the server, the leaf, but I also know if something has changed in the graph. Did the server was deployed and now it's not deployed, so that it's actually removed? Or was it undeployed and now it's deployed? So I know exactly how I need to react. Sometimes I will need to create a new expectations and put that in my store. Sometimes I want to remove an expectations to make sure I don't get false alarm. It's equally important. I remember this client I was talking to, he was telling me every time they do maintenance windows, they turn off the monitoring of all the pod. Because as soon as they remove one device, everything starts blinking everywhere, and they just cannot dynamically update that, so they just turn off everything, which is probably not what you want to do during a maintenance window.
This is when you have it, want to turn it on.
Either you're getting 2 callbacks if something changes, or your code has a bug.
Mm-hmm. There is no bug.
Because if the path updates, then I have to delete the old one and create the new one, and you're just creating the new one.
So the idea is that if you update, you will just overwrite what's there, actually, because the way it is defined is you will replace it in the store.
Okay, if the key is the same, yeah.
Yes.
So let's do the before and after. I will go on my device. I will take the same one, leave 2.
Nice try, though.
And if we look here, we have all the telemetry that we collect out of the box, and we can collect more. You can create your own, but out of the box, we collect the state of interface, BGP, the MAC. The one we're interested here is the LDP. And you see here, we have what we name an expectation. We have 2 columns. One, that's what we collect from the device, what I actually learned from LDP right here. And this is what my app has defined as what I expect to be. And if both the expectation and what's in the network match, then everything is green. As soon as something changes, I will start to report alerts. And everything is dynamic. Like I have this agent that is subscribed to those states, and every time something changes, it's automatically notified. What you see here is that I'm collecting some data from the servers. I actually have LLDP running. I see that, but I don't do anything with it. So it could be missing or wrong. Nothing will happen right now because I have not expectation for it. So when I will push the code, you will see that those 2 boxes will get filled. That will be my expectations, and everything will turn green now. So let's do that, and then we'll try to actually create some changes, because a friend of mine used to say that network automation demo are boring, because you just press a button and wow, and you actually don't see things happening in the background. So we'll actually try to go on the server and, for example, create some error, some condition that will trigger these alerts.
Before you do that, I just wanted to go back to that first point that we made, that again, we don't want to be selling it the architecture. The key aspect here is how to develop these features at a high velocity and testable and maintainable. And I think what we have done today, to summarize, is we have extended the schema, we have created Facade APIs, we have rendered new configuration based on this new schema, and we have generated new expectation based on this. And I think the totality is about 6 files and 300 lines of Python.
Yeah. So the code has been deployed. So now if I go, you see, I don't even have to refresh the page. It gets updated automatically. And now I have 3 active tests running continuously every few seconds on my network. And I make sure that I have this server on the right place, exactly where I expect it to be. On this session, I'm connected on SSH on this server. So I will just turn off LRDP. And a few seconds after, you see that my system immediately detects that now this information is missing and is triggering an alert. So if the server gets moved, if it's actually on port 2 instead of port 3, that will automatically show up, and it will tell me that. Yeah.
Question. So if you look at configuration, especially in your case, they all look like Cisco, right? So it's not so difficult to understand and parse them. If you look at telemetry, it's a jungle.
What do you mean parsing the configuration?
Getting the
existing operational state.
Yes.
So if you look at telemetry, every vendor, different tests on the same vendor will give you a completely different set of counters, meanings, context. How do you reconcile the meaning of telemetry? How do you make it useful in context of graph?
So do you mean like normalize it or homogenize it so that it doesn't necessarily mean 2 different things?
Yeah.
That would be something that you would have to communicate with the developer, right? Because it could be any platform, and it could be any counter, and you would have to know what those differences are, and make the developer aware of them. That's not necessarily the format you want to look at it. You want something that's more consistent.
So I think we could have, and Jeremy will be an expert on this, we can spend 2 hours on our telemetry plugin. But to decouple it, there is a telemetry plugin, which is the one who is responsible for collecting what we call raw telemetry and parsing all of this. And this is actually reference design agnostic. Now, how do you map that data in the context of reference design is another aspect. And I said, there is an answer, but it takes longer.
Okay, we'll take it after.
Yes.
It'll be the next NFT session.
Yes.